So we are going ahead with the banking application, but there's a twist to this banking application I want to do. It will be able to do deposit just like everything we did the last time, but you will see that we are now using object-oriented approach to do it. Then I want to be able to see the transactions that I did, more like a statement. I say, okay, withdraw, deposit, withdraw, deposit. Then I want to be able to see my statement. So we'll be able to test transfer. So you should be able to transfer from one person to another person. We will not need to do input. We'll just hand code all the information. When I mean hand code, we'll just say create new bank account for this person. Then we'll just demo transfer, and then we'll see the whole thing work. So we don't need to go ahead and do the whole input and what have you. I will not do transfer for you guys, obviously. I want you guys to look at how the transfer is going to work. So the base class is bank account. The next thing we want to do from here, we want to initialize when we create our bank account. Of course, the bank account of someone that wants to create, we have some information. We need the account number. That's to set the bank account of the person. So this bank account is a class that is going to eventually become an object. Then we need the name of the person. Then obviously balance. Balance is going to be default, is going to be 0. So you can just leave it like that. Somebody can open a bank account with initial balance. Imagine you go to a bank and then you open an account. Of course, you can have initial deposit of value. So this can be optional. You can say, okay, no. Someone should not be able to open an account with a balance. Once you open an account, you should run a deposit procedure. That can be something else. So all these are optional things that you can do. So you can even remove it. So if you want to deposit, run a deposit command or run a deposit procedure separately. Open account, keep at one place. If you want to deposit, run deposit separately. So that can be a thing. Now that we've created that, how do you then set the value of the properties? So we have two properties, guys. We have the account number and then the name of the person. So how do you set it? By using the self. Remember I told you the self is something that the developers came up with, and then it's something everybody started using. So but it's good to follow best practices, because you'll be modifying people's code and you want people to be able to modify your code too. Another thing is that you make sure that the name you call this one here matches. And I'm using abbreviation because my screen might not permit me to extend too much, but you can go ahead and put the whole thing in full. Sometimes it's good to be explicit to express what it is you are trying to say in your parameter, because sometimes your short form might not really literally mean the same thing. But we always know that ACC is account and NUM is number, so it's a very good abbreviation. So we can just go like this. So we have that settled. You can also do your name as the name of the person to be this, and that is done. Okay, so that said, another thing you want to denote is that you want to also note the balance. Even though you don't want people to be able to pass the balance, doesn't mean that you cannot set the balance yourself. You can actually set the balance, and in this case I just set the balance to be 0. Now we are done with this part. What other thing do we want to be able to do? We can then go ahead and start implementing deposit, withdrawal. I want to see the one I want to do for you guys. I think I should just do deposit for you guys. So let's do deposit, guys. Remember, I'm still creating the template, or I'm still creating the class. Yes. The next thing we want to do is to create another function, which is the deposit. So we go to the dev and we do deposit. Specify what are the things we need to do with deposit. I need to access some properties for myself. So you pass self there, and what parameters will I need to accept when I'm doing a deposit? I need to know the amount. So I have the amount there. So what will this amount update? Of course, the amount will update the balance. So I can then do self.balance is equal to, of course, I need to know the previous balance. If you do something like this, it will just be overriding the balance. So you need to have idea what the balance is before. By default, your initialize it to 0. So meaning this is safe. You can then go ahead and do this plus this, or you do a shorthand by doing something like this, right? I hope this is clear, guys. So let's move on to the next thing. So this is deposit. So I'm doing the surface. Now you will know, you agree with me that if you want to write a statement for this transaction, you agree that at the point of deposit, you need to put a log that says, hey, somebody withdraw money from your account so day. Do you get? You need to be able to do that. And that will be somewhere around here, before or after. That's where you will do that. And I will give you guys a clue on how to handle this. But let's go ahead and first complete the system. So you can see how simple it is, guys. We are done with this one. And at every point, you can either print to the console that, hey, your deposit has been done successfully. But you don't need to be printing. You can just check balance to see what happens. So it means we need to also do check balance. And check balance is going to be very straightforward. So here, it's going to be opposite of these guys. Just opposite. But you want to do a check. You want to check that the person has money before you are doing this. You know, that the check can be there. Very, very simple to check. Just do an if. You know, once I don't want to write that code. That code is simple enough, guys. You do an if. What are you checking? If the balance is more than what you want to withdraw, allow the withdrawal to take place. If not, say you can't withdraw. So let's save time. These are things you should be able to do by this stage. So be able to check that and then move on. So I'm assuming that you will do that part. I will do transfer, but of course I will not define it. I will just say pass. Then what else? Check balance. Notice the way I'm writing the function, guys. Small case, small letter, small letter. This starts with capital letter. Notice the way I write all these things. It's very important. You don't use capital letter here because this is a variable name. This is how you most of the time define your variable names, all in small letter. Your classes are always in title case like this. We implement check balance, very simple. We just say, at this time around I can use print. You can use print, or you just say it should return the balance, but let's just print. Of course we need the self because we want to use some details about the person inside here. So I'll say self name account balance is self balance. What else do I need to denote here? Yeah, you can do any string concatenation you want to do here. Pretty straightforward. Then statements. You might want to do statements. And this one, so I'm going to pass. I'm not going to do this for you. We're pretty much technically done writing this. Let me clear this so that I can have more room up here so that I can see the code at a glance. Now, this guy is defined. The next thing we want to do is us making use of the program. Look at where I start up, guys. So the program wants to start now. And you can do input if you want to do input. Like I said, I'm not going to use input. I'm just going to go straight ahead and start using it. I say account 1, like this first person, the first person that I want to make to use the system. I want to create a bank account for this person, and I want to start using the class I just created, which is this. So I want to say, what is the first requirement I will need? The account number. So you can use any method you want to do to generate the account number. So all these ones are just you can do that, but you already know how to do all those things. Then the name. So this one is now being able to pass those things yourself manually instead of dynamically capturing it using input. So this way, it allows you to test your class quicker than just creating an interface to accept all those things. This account 2. Then this is James. This is Michael. Then we have the 2 accounts. You can create as many accounts as you want. So that is done. Account creation. Then you can go ahead and test things out. So you can do a deposit and say deposit. How much do you want to deposit? 500. And at the end, you can do as many as you want to do. You can deposit again. Maybe this is another day that it came. It came to deposit 600, the next day or something. Then you can go ahead and do account 1, then check balance. So the check balance is going to print because we said it should print. So depending on your implementation, you might just write the print here, but it's fine this way. Polymorphism is allowing me to be able to use the object to run the same function. What that means is instead of me printing here, I can create another general function, and the purpose will be to print balance. and I can say I want to accept bank account. So once I accept bank account, what will I now do here? I will now say print. What am I printing? I'm printing bank account. I'll pass bank account to that function, bank account dot check balance. So what that means is, instead of me saying check balance, I will just say print balance of which account? Of account 1. This is polymorphism, guys. We did that yesterday. So you could see that I have various options in which I can achieve the same aim or the same goal. So in this case, my check balance is returning the value of the balance, not necessarily printing. So I can then do this to return float, so that I can then say return this. So that in this case, if you now pass any bank account you pass to this and you say print balance, it will now print the balance for you. Now you can now express yourself, instead of just say print balance, you can express it normally. The same code we wrote there, you can still say the same thing here by saying, I think it's a safe time for us to do a test. So if I run this for the first time, you can see that it gives me the balance. James' balance is this value, which is correct. So you can do as many tests as you want, just to make sure that your code is working. So if I run this, it gives me this new value. So you can also try balance of account 2. So obviously account 2 will have 0 balance, obviously. So it has this. In fact, let me make it print the next guy, account 1 and account 2. So if you run that, you have James has this, Michael has 0, because we didn't do any transaction under Michael. Now you look at this and tell me, doing it procedural way or functionally. The method we did before was functional. This method is object oriented, using object oriented method. That's how you do this. And you can easily tweak whatever you want to tweak in their respective functions. So if something was wrong with deposit now, I fix my deposit here and I'm good to go. So if tomorrow the bank changes their mind that they want to start collecting charges on every withdrawal, like they do now, on every deposit, they want to start collecting charges, where do you think we'll go and put the code? We'll just put the code here under deposit. Under deposit, remove 0.00%. You put the code here. Everybody's life will be easy. Imagine how stress-free this will be, just knowing that you just need to go to one place and fix stuff. That's the power of functions and classes. So you don't need to go through all the implementation of your code to say, you did one thing in one function, you want to run to another function to make an adjustment. Go ahead with your question.
Okay, sir. No, I think I already know the answer to this, but I just want to ask again. So why did we have to go through that
functional approach?
Yeah, the functional approach. When we know that this one is straight to the point.
No, so if you look at the whole thing, look at this part. Do you see this part? From 25 to 32. Does this look object oriented? No. So the functional approach is still needed, because even inside your function, you still write procedural. So they call it procedural and object oriented. So be deep down to the granular part of your code, you will still write something like this, that will make use of those functions. So you needed to know how to do basic operation with all your keywords that you've learned. You still need to know how to do that. So this is now you structuring your program, because this is now structuring. You are structuring your program to make it more manageable or make it easier for you to maintain over time. Everything about what we are doing is for the future. If you want to be able to do a transfer, what do you think you need? Of course, you need to know the person.
Recipient.
Yeah, so you need to know the recipient, and of course you know that me and myself. So you can see this person. This one is the person that is initiating anything. This account person, this HACC1 holds the account information. So, and we can perform several operations on the object, deposit, withdrawal, and things like that. We already know the initiator. So this is the initiator that is starting the process. We already know the initiator. The next person we need to know is where we are sending it to. So where we are sending it to, remember, is also or is going to be an object. It's going to be an object that is called bank account. So it's going to be an object called bank account. That means that I'm supposed to be able to do account1.transfer. Now, remember that I already know myself. That's why you're not seeing self here. Don't let this confuse you. Don't let this self confuse you at any point in time. The self is referring to itself as an object. And that's why it's a perfect word. And that's why that name sticks and it becomes, what everybody is using. So that self refers to itself. And that's why when you are using it, you will never see that function, being labeled. It's already inherited. The self is this. The account one is the self. The next argument is now the bank account you want to transfer to. And that's why it's saying account one transfer to another bank. So the solution to this is, let's say I want to transfer money from account one to account two. Know that account two does not have any money. So this one will be account one dot transfer to, what do you think will be here? Account two. Now, how to make the money enter this place is not your responsibility. So that is the assignment. How do you let that money enter into this place? That's the code you are going to write here. So the next thing I want to address is the statement. You need to be able to memorize all the information you are doing, all the transaction you are doing. Look at what happens here in the deposit. We deposited, we didn't keep the information. So let's say we have 400 here, and then we have 200 here. Then if I run this now, we now have 600. Yeah, we have 600. Then when I deposited this 400, there's no memory of what happened. It's lost in the program. The new value that I see is 600 after the program has run. So how do you do this? So I will give you Expo as usual. When you initialize, you need to also have another property that keeps statement, another attribute that its responsibility is to keep a log of all the things that is happening. So I can call it any name, guys. So I'll say self dot, I can say transactions. So now you are not left to remember that it's going to be a list, or it's going to be something that is going to be, incremental. Because imagine now you have 400 went in. So it needs to be something that you can be adding to and keep the memory. So we will need to have either a dictionary. I don't think you should use a dictionary. Don't worry, don't use a dictionary. Just use a list so that you could just append to it. But if you want to go detail, you can actually use a list where your list will now have the date that the value was posted, and if it's a credit or debit, you can do that in dictionary. Key and value. So your key then be the name of the property. So if you are doing transaction type, you can say type, then you can put deposit or credit, then you can say amount, and you can put date. So you can have list of dictionaries, or you can just have list in there. So now that you have a new property, sitting right here, you can then, at the point of depositing, what do you think you will do to this dictionary? You add something inside. I won't write the code. You add something inside the transactions, so that when you are depositing, it will capture this guy. Immediately you deposit, it will add 400 to the list. When you do another deposit, it will add 200 to the list. What do you have in the list now? We have 2 items in the list. So when you say print statement, you will see those transactions. So the reason why I'm saying that it should be a dictionary is that we will now have where it will say credit or debit and the amount properly labeled. So let me show you another thing that you're going to be needing, and that is if you want to use date and time. So if you want to use date and time, you can do from date time, we're importing date time. Let's see how to use it. So to use it, you will use date time. So let's just print something out, guys. So it means you'll be able to do it that way. Let me just say print date time dot. So it's an object that has all this information. So you can actually print the current date or the current time that we're in now, and that is called now. So when you run this now, it will print out the full time that we're in now. So let me run it so that you see the results. So you can see the full time. So it goes to this, so you can have this. So this is a way for you to capture, oh, when was the transaction done? So imagine you are depositing now, and then you want to load this time in the transaction. Of course, you are not putting it here. You are putting it inside the code of deposit. So when you are logging the transaction information, you can say, oh, this was the time that transaction was logged. You can also do a delay to create a kind of delay. So all those things, I will have a class to explain standard libraries. I will also show you how to do a delay if you want to simulate like 2 seconds delay. Like if we run this now, you want it to simulate 2 seconds, 10 seconds. I will show you how to do that with another class. Now that we finish this one, obviously you should know how to print your statement. So this, you can print your statement like this. You can also write another class to print statements, guys. So you can say print statement bank account. So what this means is that any bank account that you put in there, you should be able to print the statement. So you can write, so it means you will loop through the transaction. No, you're not looping through the bank is one object. So yeah, the transaction is going to have list. So you are looping through the list of transactions to create a table, so that it will look nice here. Another twist I want you to do here is that I want you to be able to do savings account. Let me just start it for you, but you will do the rest. So I want you to be able to create savings account, a new class for savings account. So let's do that here. This is normal account, guys. This is bank account. So if I have class, and I can call this current account, or you can even say saving account and current account. So I can come here and say saving account. So meaning we now have two kind of accounts. So I'll say pass, so that to let us write our code, and you say pass to let us write our code. In fact, you can go crazy, guys. You can even say you have fixed account. So you will now start writing a lot of procedures. So for fixed account, you can't withdraw anytime now. There's a procedure for fixed account. So when you now try to withdraw, it will give you an error because it will say you can't withdraw on a fixed account except you run some procedure. Maybe someone needs to sign off that, when you want to withdraw from a fixed account, you need to first do some sign up and everything before it to allow you to withdraw. So, and creating the proper account is very important so that there will be control in the system. All these are because of control. It's not because we just want to write fancy program or something. It's because of you are trying to solve a real scenario in a business sector. That's why you have everything separated. Imagine we want to write all the logic in a class. Do you see how crazy it will be? You now put a type here, and in this type you now say, oh, when the person is creating it, now I'm creating it. I'm now saying savings account. Now I've given myself problem because inside each of the deposit, transfer, withdrawal, I will now be checking if it is saving, if it is current. If I don't need to do that, because once I have a class that does what it is I say it should do, I will just implement the peculiarity of savings account inside savings or current account inside current. So therefore, I can then say, okay, so let me inherit our guys. You know how inheritance work now. So I will just say bank account. So I will say savings account inherit bank account, current account inherit bank account, fixed deposit inherit bank account. In fact, you can do some crazy manipulation or some crazy gymnastics depending on how the hierarchy of the tree is. Do you know that you can actually let current account inherit savings account? You could actually do this. So that means everything that the savings account has is what current account has. By extension, everything that bank account has, current account already has it. But what we are doing is this. This is your assignment, guys. I've gone ahead to do the extension for you guys. You can then do COT. Yes, that's a very good one. Charge tax on deposit and withdrawal for current account. Just for this, just to play around with this. So it means when you are implementing your withdrawal and deposit, you will need to, charge tax deposit, and you must be able to demonstrate it in your code. So let's say we want to now, do current accounts. We want to create a current account for somebody. So let's go ahead and create account 3. Account 3 is equal to, so we just say current account, and then you'll be able to put the current account number, and you then put the name of the person. Let's say buyer. Of course, the system understands all these other things that it's doing. So you can do, let's deposit, because it's a current account. The guy must have some serious money. Let's put like 1 million there. Let's print our current account. So if you run this now, so you should see something like this. Buyer balance is 1 million. What I want you to do under this one is don't allow withdrawal until a condition is met. So let me help you with this one a little bit. By default, the account can always be locked. Fixed deposit is always locked by default. So what that means is if you create a fixed account, if the locking is not off, the withdrawal should not work. So how can you implement that? So let's go ahead and implement this one. So let's say withdrawal. So because we now have something different for this, of course it means we need to run the initialize stuff, and then we then need to implement something different for this one. I want to see the way I wrote it. I want to copy exactly the way I wrote it so I don't miss anything out. So I put it like that, and then I depend on the super guy to call the guy, and I pass in all these guys inside. But I'm not done, guys. I'm not done. So this is where I implement the flag. This is where I implement, because I want it to be unique to fixed deposit. So I now say lock. I just say lock. I say lock is equal to true. So by default, you can't withdraw anything from this account. So whenever you want to withdraw, so it means you will override this withdraw guy. You have to override it. So withdraw is not automatic. So you have to check every time. You have to check every time. Is lock false? If lock is false, then you can do that. So it means you then need to be able to have another function to unlock your funds. So then you can do unlock here. Unlock, you're unlocking self, and then if I say lock, then it will be true. So that way you can toggle that, oh, this account should be locked or not locked. So if I'm creating another account, and this time around is a fixed deposit, so I want to create a fixed deposit for somebody, and I say this time around this is this is that, and this is Janet. So this is account 4, and you can run this operation on account 4 now and say, okay, account 4 loaded 5 million. So I didn't write the condition for withdrawal to not allow me, but you can toggle write code like say unlock, so unlock should be able to unlock the fund for you. That's what this unlock should be able to do, and you should be able to also lock. So if you did not call unlock, you will not be able to withdraw. That's the idea. So I've not written the code for that. So that's the assignment that you guys will do. So let me highlight the assignment, guys.